Section 11.3, a combination is a counting arrangement when order does not matter. Example, there are 20 students that try out for the basketball team. There are only 15 spots on the team. How many ways can you select a team of 15 from 20? Okay, order wouldn't matter because they're on the team. It doesn't matter who was the first pick, the last pick. There are 30 employees at a company. 2 employees must be chosen to attend a conference. How many ways can 2 employees be chosen from 30? Okay, they're going to the conference. It doesn't matter who is the first pick and the second pick. So order does not matter. These are called combinations. The formula for a combination, we say C of N choose R, or we can also write N CR. N is how many to choose from. R is how many are selected. In the formula, you put N factorial on top, N minus R factorial in parentheses on bottom, and R factorial also on bottom. Examples. 3 people must be chosen to be on a committee from 8 people. How many ways can this happen? Order does not matter. Okay, they're just on the committee. So N equals 8, we have to choose from 8. R equals 3, we're picking 3. So we would put 8 factorial on top. On bottom, we put N minus R, so we're going to put 8 minus 3 in the parentheses, factorial. And R factorial, so 3 factorial on bottom. Okay, let's write these out. 8 factorial means 8 times 7 all the way down to 1. Okay, 5 factorial is 5 times 4 times 3 times 2 times 1. And our 3 factorial is 3 times 2 times 1. Okay, now let's see what we can divide out. You always want to pick the bigger number on bottom. So we've got a 5 through 1 on bottom that will divide out with 5 through 1 on top, which will leave 8 times 7 times 6 on top, 3 times 2 times 1 on bottom. And then divide, so you get 56 ways to choose 3 people from 8. A person is dealt 5 cards from a deck of 52 cards. The order does not matter. How many different 5-card hands are there? So N is the 52 cards to choose from. R is the 5 cards to pick. Okay, so it's a combination of 52 choose 5. N goes on top, 52 factorial. On bottom is N minus R, so 52 minus 5 in parentheses, factorial, and then R factorial. Okay, we do what's in the parentheses first. So 52 minus 5 is 47. Now, we certainly don't want to write 52 through 1. So what can we do instead? Notice that we have a 47 factorial on bottom. What that means is 47 times 46 all the way down to times 1. Okay, so if we stop at 48 and then say times 47 factorial on top, that 47 factorial means 47 all the way down to 1. And now we can divide it with the 47 factorial on bottom. Okay, 52 factorial means 52 through 1. But we don't want to write all that. 47 factorial means the 47 all the way down until you get to 1, which will cancel with the other 47 factorial. They'll divide out. So we just multiply on top, multiply on bottom, and then divide. To win the lotto in Florida, you must correctly guess 5 numbers from the numbers 1 through 59. Order does not matter. how many different lottery tickets are there? Okay, so you choose from 59 numbers, so that's N. You pick 5, so that's R. So we're doing a combination of 59, choose 5. So we would have 59 factorial on top. On bottom, it's N minus R, so 59 minus 5 in parentheses. And then R factorial would be our 5 factorial. Okay. Now let me erase this. Okay, so what is the 59 factorial on top? Okay, let's hold off on that. Let's look at what we have on the bottom. 59 minus 5 in parentheses equals 54. We do that first. So on 59 factorial, we don't have to go all the way down to times 1. We can stop at 54 factorial on top to divide out with the 54 factorial on bottom. Okay, on top, what does 54 factorial mean? That means the rest of the 54 through the 1. Okay, so those will divide out. On bottom, we have 5 times 4 times 3 times 1. Multiply that out, multiply the top. Okay, and gives us over 5 million lottery tickets. Okay, so the 54 factorial, those on the top and bottom divided out. So you just multiply 59, 58, 57, 56, and 55. And that's the end of this section.